Hello, NR426. This is the video lesson for Lesson 6, Creating Script Tools. In this lesson, it'll just be one class session, so nice and short. And in this lesson, we will cover how to make Python scripts dynamic using arguments so that the user can enter in values that they want to pass in for variables. And we'll also get into how to turn your Python script into a toolbox tool by going into ArcGIS and just filling out a little wizard. So we'll start off with why we would even want to do this. So why attach a script to a tool? So first of all, when you do this, it becomes part of what's called the geoprocessing framework. So all of those tools in the toolbox in ArcGIS, they can then be run as a dialog box, so very user-friendly interface. They can become part of the model builder, so if you ever wanted to use models, they could be plunked into a model. There are other ways you can run it, so you could run it from command line from like the Python window. It's easy to incorporate environment settings, so if you wanted to set environment settings in ArcGIS for things like a default workspace, a default coordinate system, a default cell size. When you have the tool as a script tool, it's really easy to do that, and every time you run the tool, you can pick a different value for that. And then lastly, if you have something more complex that maybe will be shared that you need documentation for, it's really easy to set up a help file for it, like documentation, so that other people can know what the script is about. And I already mentioned this, but there's also the big benefit of having a user-friendly interface to run the script so that you can create a script that does some complex custom functionality, but then anyone can use it without ever having to look at code. That's key. So non-programmers can run your script without ever having to go into idle or PyCharm. And then the other really great thing here is that the dialog box can help prevent errors. So a lot of the things that I've been drilling into this semester about putting in if statements to check for data types, to check for data existence, you can build those into the dialog box without code. So it actually makes it easier to run those checks without having to build it into the script. So in the end, you might have a custom toolbox like this right here. And in the end, you would have a script tool like this one right here. And any script tool will have an icon like that. And then when you double click on it, you would set up the parameters that would go in the dialog box. And you set up these parameters in a wizard. You don't have to write the code to build the dialog box. If you want to know a little more about it, there's some really great help here. And just so you know, the supplemental reading for this lesson is actually a PDF that I'm giving you. It's a chapter from the Advanced Python book, which this was a topic that used to be in the regular book, but then they moved it to the advanced one. So I'm giving you that PDF so you have it. So take a look at that. Moving on. Okay, so how do we incorporate scripts into the ArcGIS interface? First of all, you need to make your scripts dynamic. So step number one, make your scripts dynamic, and you do this in your IDE. So in idle or PyCharm, you would actually have to modify the variables that point to the data or point to the values to be used in the tools, modify those to make them a user variable. GetParameterAsText or sys.argv are the two that we'll be using. Now we have used input in the past in this class, but that doesn't actually work for script tools. After you do that, then the next step is to attach the script to a tool, and that's done in ArcGIS, and it requires what's called a custom toolbox. A custom toolbox is any toolbox created by a user, a person, as opposed to the toolboxes that come with the software like analysis, data management, spatial analyst. All of those ones are called system toolboxes. They are read-only. We can't make our script tools in there, but you can make your own toolbox and put your script tool in that one. And then after you start that process of creating a custom toolbox, set up all your tool parameters and properties, and then you can run it. Let's talk a little more about how we make these scripts dynamic, because this is a pretty big, important first step. So scripts can be what's called static, hard-coded, or dynamic, or flexible, user-friendly. So up until now, all the scripts that we have written have been what we call hard-coded or static. So anytime we had an input data set, an input workspace, an input cell size or buffer distance, they have been hard-coded, like the value for it has been typed into the script. So what we're going to do now is shift and make arguments for those variables to make the script dynamic. So there are 3 ways to create arguments: sys.argv, which is a Python function, and it uses the sys module. arcpy has a method called GetParameterAsText, and that's an arcpy method. And then there's also the Python function input. We won't be using that one in this case, but we'll be using the first 2. So let's take a deeper look at those. GetParameterAsText is typically the preferred method, and it uses arcpy, so it's arcpy.GetParameterAsText. So we'll be using arcpy anyway, so there's no need to import another module if you weren't already going to import that. It's important to note that the first argument, when you're numbering your parameters that you add in, it starts at 0 because you might have multiple. And then here there's no limit to the number of characters, and we'll see what that means in just a moment. But let's say you started out with a script and you had an output FC future class that was going to be created. Instead of having output FC equals C student mydata.shape, instead of having that hard-coded in here, we will literally just replace that code with arcpy.GetParameterAsText, and then you number it in parentheses starting at 0. So if you're going to have 3 things the user has to pass in, it would be 0, 1, and 2. And each of these now represent placeholders for what the user will eventually plug in over here in the finished dialog box. So each line in the code corresponds to an item in the dialog box, but you have to know your code and what it needs so that when you set up the dialog box, they correspond to each other. So once you create this right here, then you have your variable output FC, and the rest of your script will be the same. All you're doing is changing how those variables are defined. So this is what it would look like if you use GetParameterAsText. Now this is what it would look like if you use sys.argv. This is what it would look like if you use sys.argv. So because it's sys dot, you need to import the sys module. In this case, the first argument starts at 1, and you may be thinking, what? Why does it start at 1? Why doesn't it start at 0? Because computers like to start at 0. The reason for that is because the 0 argument for sys.argv is actually the name of your script, whatever.py. So that's your 0. So the first real argument that the user puts in is number 1. There's a limit to the number of characters. I believe it's 2,500 characters, which is pretty big. You would never have a path name for a data set that's that long, but if you were reading in some type of comment field from a table, like a text field, or maybe multiple lines of things as one argument, then that could be a limiting factor. Here's what the code would look like. So we have import, arcpy, and sys. And then let's say we're setting up a workspace. It would be sys.argv1. So instead of passing in the path right here, you just set the workspace equal to whatever the user enters in, and then the rest would be the same down below. Here we have examples for setting up something to do buffer. So we have sys.argv2, 3, and 4. So that's what that would look like. Now let's take a look at some actual code and see what it looks like for real. So let's say this was our script. This is a completed script. We'll be walking through this code during the demo, and then you'll be using different code in the exercise. But here it's very basic. We don't even have header code, but we're importing arcpy, and then we are trying to do some things here. So this is what we would call a hard-coded script, because we are setting our workspace equal to a path. So it's hard-coded in there. If we ever wanted to run the script on different data, we would just have to go and literally overtype that and put in the new path. Same thing for the second one, where we're creating a file pointing to a text file. And what we're doing is opening this text file in read mode, and then down here we'll be reading in the lines from it. So this is what we would call a hard-coded. When we have hard-coded scripts, it makes sense, it's a best practice to put anything that might need to be changed up top. That way, if you do have to change it, it's easy to find and you don't have to look through all the code to find those paths to update. The other best practice is to make things have relative paths. So things like setting a workspace, and then anything inside the workspace, like fire incidents is a layer inside that geodatabase, setting it relative to this and not putting a path right here. If you put a path right here, if you did all that in here, then you would have to update this path and this path. So whenever you can, use relative paths, and whenever you can, use user arguments, because it's just easier to update. So if we wanted to update this for use in a script tool, all we would do is set the workspace equal to arcpy.GetParameterAsText, and it starts at 0. So when I have it like this, what it means is I can't just go and run the script, because now the script is waiting for the user to put something in here. So I can't just go and run the script like this. There is a way to plug in arguments when you run things from idle and PyCharm as well, but typically we would only do this here if we are going to a script tool. So I would want to change that, and I would also want to change this, and I might give it its own variable. So arcpy.GetParameterAsText 1, and then when I do the open, I would pass that in like that. So that's just a quick way to show you how we can update our code like that. Now let's look at the finished product. I do have another version of this open. So here, same thing. Here's the same script, and here we have output FC, F-class template, and F. And here we're actually using the open line with the GetParameterAsText in the same line. In this script, what we're doing is reading in a text file and then creating an insert cursor on a layer. And in this one here, we're actually pointing to a layer that's already been made. So we're pointing to a layer that's already been made, creating an insert cursor on that layer. And then we will be reading in, see how we're doing read lines on that text file? We're reading in everything in the text file here. We're grabbing the latitude value and the longitude value and confidence value. And then we are setting the new row to be equal to those values and then committing the change. So what we're doing is reading values in from a text file and plugging those into a new layer, and we're actually plugging it into the shape field. So we're creating new points in a point layer using the script. So this script is pointing to a layer that's already been made. The finished product is allowing the user to set the name of the layer they want to create with these new points. We are creating what's called a template. We're letting the user pass in the value for a template layer that already has the field structure, the schema set up. And we're letting the user pass in the text file that they want to use to get the coordinates from to create that point layer. So this is actually a really great example for anyone who might have a text file of coordinate values that you want to turn into points. There's a tool for that, but this is another way that gives you a little more flexibility and a little more control over how the points are made. So this is the finished product. We have a script with 3 user arguments, but that's only half of the process of turning it into a script tool. The other half of the process is to go and actually make the script tool in ArcGIS Pro. So let's wrap up this video and we'll start a new video where we will get into that half of the process.